Hello. A couple of years ago, I wrote this blog post about nutrition tracking using Emacs. The idea was that I created some org capture templates that allowed me to capture things like foods, for example, egg white, and also capture its nutrients breakdown. Then I was able to use those foods, those ingredients, in order to compose things like recipes. In this case, we have an omelette with double egg and egg white, which allows me to capture which are the ingredients in this recipe, which are the quantities, and for each ingredient, how many calories, protein, carbs, fats, and stuff it has, in order to finally allow myself to capture whole meals. For example, for today, let's add an omelette with double egg and egg white, single serving, and when I press Ctrl C, it is added to a table that holds the meals that I'm consuming each day, and it sums up all the ingredients, their calories, proteins, fats, carbs, and more. And the end result looks a little bit like this, which is a table that I end up aggregating in another table in order to break down my daily calories, carbs, fats, and protein, which gives me the ability in the end of the day to do something like this, generate diagrams and all those cool and useful stuff. So I wanted to take this thing a step further, because one of the major pain points in this whole process is that it is pretty hard to maintain and add new foods in this file, and the main difficulty behind that is that it's hard to obtain the nutritional information, how many carbs, calories, fat, protein, and stuff each food has. So I was wondering if I could use a package like gptel, which allows Emacs to talk with LLMs in order to fetch those values from the LLM each time I'm capturing a new food. So let's see how this looks like. I'm going to nutrition, food, and I will add something like brown rice. Its basic quantities usually in grams. I usually consume 180 grams of rice, so this is a typical serving for me. And I will skip calories, protein, carbs, and fats, which I would like gptel to fetch them for me from ChatGPT. So when I finally end up pressing Ctrl C, it will delegate to ChatGPT and get those values from there, and finally update the org table. And let's see what it added: brown rice, and these are the nutrients, which is pretty cool. Now, how I implemented that, let's go to get to the functions. I think it's get nutrition or something like that. We'll find it. Get new functions. Okay. Yeah, it's nutrients get, not get nutrients. Okay, that's why I couldn't find it. So this is the core functionality, a function that accepts two arguments, food and quantity. If no quantity is specified, we assume that we are talking about one serving. The message that we pass to the LLM is that provide the nutritional values, calories, protein, carbs, fat, and only return a JSON object that contains those keys. And finally, we return that JSON object as a map, and we implement I implement a secondary function that is called as post-processing each time I'm doing a org capture, which goes to the heading of each food element. It gets all the entries from there, calls the nutrients get method, and finally sets those values and updates the org table. In the end of my code, I'm also registering this as a hook to be called each time I'm doing the finalization of org capture, and this is how it works. And I think that it is really cool and really useful, and I hope that you find it cool and useful yourself. Enjoy!